We now turn our attention to equations in two variables. And we find that the solution sets of an equation in two variables look very different from the solution set of an equation in one variable. Recall that when we looked at equations in one variable, we followed a series of steps to get the variable alone on one side of the equation. And we typically found one unique solution. When we have an equation in two variables, we typically have many solutions. For example, if we look at the equation x plus y equals 4, note this has two variables, namely x and y. If we look at this equation, it's easy to see that there are lots and lots of different choices for x and y. Right? We could have x equals 3, y equals 1, for example. That's a solution because when I plug those in, 3 plus 1 does indeed equal 4. Recall, a solution to an equation is just a list of values for the variables that make the equation true. But also, x equals 2, y equals 2, 2 plus 2 equals 4. We could also have something like x equals 12, y equals negative 8. 12 plus negative 8, still 4. We could even have something like x equals 1.73, y equals 2.27. 1.73 plus 2.27 equals 4. We typically have many solutions. In particular, for the kinds of equations that we're going to talk about for linear equations in two variables. Any choice of value for one variable gives us one solution. So if we choose x equals 3, the solution x equals 3, y equals 1 is one solution. Even though it consists of two numbers, those two numbers go together. So that makes up one solution to the equation. X equals 2, y equals 2. This is another solution. Alright, I said that's true for a linear equation in two variables. What constitutes a linear equation in two variables? An equation in two variables is linear if neither variable has an exponent other than 1. Neither variable appears in a denominator or inside a root. And the variables are not multiplied together. So some equations that are not linear, x squared plus y squared equals 9, would not be linear because the variables have exponents. 1 over x equals 1 over y plus a half, not linear because the variables are in denominators. xy equals 6, not linear because the variables are multiplied together. So these equations are not linear. Some examples of equations that are linear: 2x plus 3y equals 6, y equals 3/5 x minus 7, y plus 4 equals 1/2 minus 3. All of these equations are linear. Okay, so an equation in two variables typically has many solutions. In particular, if we have a linear equation in two variables, we can make any choice for one variable, and that gives us one solution. How do we find those solutions? Let's use as our example the equation 3x minus y equals 7. To generate solutions to an equation, well, we just first choose a value for one variable and then solve to find the corresponding value for the other. Now, when we do this sort of thing, it's helpful to organize our work into a table. I'm going to set x values in the left column, y values in the right column. So let's see. I might choose the value x equals 1. I might choose the value y equals 2. I might choose the value, say, x equals negative 4. Right? These are just numbers that I came up with off the top of my head. And now I'm going to compute the corresponding values of the other variable. Okay, so I'm going to copy my equation just to get myself a little bit more space. And just to keep track of my work, I'm going to label my rows A, B, and C. So in row A, I have x equals 1. I plug that in, and I have 3 times 1 minus y equals 7. So that's 3 minus y equals 7. I want to understand that minus as plus the opposite. So let's see, I need to get rid of the 3. So I'll subtract 3 from both sides. And now I need to get rid of that negative sign. So I'll multiply both sides by negative 1. And I get y is negative 4. Okay. So that was row A. Row B, we've chosen y equals 2. So we have 3x minus 2 equals 7. And again, we'll understand that minus is plus the negative. First, we need to get rid of the negative 2. We'll do that by adding 2 to both sides. 3x equals 9. We'll multiply both sides by 1/3. The 1/3 and 3 cancel, and we get x equals 3. When y is 2, x is 3. And finally, for row C, we've chosen x equals negative 4. So we'll have 3 times negative 4 minus y equals 7. Right, that'll be negative 12 minus y equals 7. Again, minus y means plus negative y. To get rid of the negative 12, we'll add 12 to both sides. We'll get negative y equals 19. Now, to get rid of the negative sign, we'll multiply both sides by negative 1, and we'll get y is negative 19. Okay, so what did we see? We saw that when we chose the values in black and plugged them into the equation, we found a unique value in green just by solving an equation in one variable. And that's our process whenever we want to generate a solution to an equation in two variables. We choose a value for one of the variables, and then we solve the equation to find the corresponding value for the other variable.